Hello friends, so welcome to MathAlcoholic. Today I'll be discussing the miscellaneous exercise of the chapter relations and functions, and I'll be doing question number 14 here. So starting question number 14, we defined a binary operation star on set 0, 1, 2, 3, 4, 5 as a star b is equal to a plus b when a plus b is less than 6 and a plus b minus 6 if a plus b is greater than or equal to 6. We need to show that 0 is the identity for this operation and each element a that is not equal to 0 of this set is invertible. Each element a which is not equal to 0 is invertible, with 6 minus a being the inverse of a. Okay friends, so let us start this. As always, we start with the given data. So it is given, let x is equal to 0, 1, 2, 3, 4, 5. Alright, now the operation star on x is defined as a star b is equal to a plus b if a plus b is less than 6 and a plus b minus 6 if a plus b is greater than or equal to 6. Alright, now an element e belongs to x is the identity element for the operation star when if a star e is equal to e star a for all a belongs to x. This by definition we know. For by definition for an element to be an identity, this must be functional with the operation and it must result in the element that is being operated other than the identity. If we consider e to be identity, so a star e must return us a, and that should be equal to e star e for all a belongs to the domain where the operation is defined. Now here we can see that for a belongs to x, by observation this is a star 0 is equal to a plus 0, that is equal to a. Also 0 star a is equal to 0 plus a by definition. Okay, that is equal to a. Now why are we taking a plus b? As clearly, since a belongs to x, a plus 0 is always less than 6 because x itself is up to 5. The set x consists of element up to 5. So if a belongs to x, then a can never exceed 5 and hence a plus 0 will be always less than 6, and similar is the case here. Since a belongs to x, a plus 0 is always less than 6. Alright, so we can get a star 0 is equal to a is equal to 0 star a. Okay, so therefore we can say that a star 0 is equal to a, and that gives me equal to 0 star a for all a belongs to x. Plain simple. Now no rocket science involved here. Hence we can say clearly that 0 is the identity element for the operation star. Okay, now after finding out it is an identity, and now we need to find the inverse of a, which we need to show that it is equal to 6 minus a for all a that is not equal to 0. So let's start now. By the definition of whether an element is invertible or not. Okay, now whether the operation is invertible or not. Operation for each element, I'm sorry. Now an element a that belongs to x is invertible. This we are going just by definition. If there exists a b belongs to x such that a star b is equal to identity, we have read this, for b to be an inverse of a. So a star b must be equal to 0 because 0 is the identity here, and that should be equal to b star a. Okay, So we can imply that, that is A plus B is equal to 0 is equal to B plus A. Also A plus B minus 6 is equal to 0 is equal to B plus A minus 6. Okay, if A plus B is less than 6, if A plus B is greater than or equal to 6. Okay, we can just replace this by this. Okay, so that is, we can say from here it implies that A equal to minus B or B is equal to 6 minus A. Alright, now since A and B both belongs to the set X, which is 0, 1, 2, 3, 4, 5, it is consisting of all positive numbers. Since A and B both belongs to this set X, it cannot be negative. So A plus B cannot be 0, in other words. Okay, A plus B cannot be 0 in any way. Here we get A plus B is equal to 0, right? It is not possible in any case. But B is equal to 6 minus A or A plus B equal to 6 is always possible. In many cases, if A equal to 3, B equal to 3, if A equal to 4, B equal to 12, vice versa, like that. Okay. Now, but for A is equal to 0, you see, for A is equal to 0, B equal to 6, which exceeds this set. Hence, if A is not equal to 0, you can clearly see. So we are going to write this by language, but X equal to 0, 1, 2, 3, 4, 5 and A comma B belongs to X. Hence, A not equal to minus B. Okay. Therefore, B is equal to 6 minus A is the inverse of A for all A belongs to X and A not equals to 0. Okay. So hence we can say that A inverse is equal to 6 minus A. Okay, since we get B like that, very easily we can conclude that A inverse is equal to 6 minus A. You can add it further for all A not equals to 0. So this completes the question, friends. I hope you have no doubt. If you have any kind of doubt, please feel free to use the comment section. I'll be returning with question number 15 in the next video. Thank you very much for watching this video.